Students, class 10, let us go through modern periodic table and let us understand what are the trends of modern periodic table. Actually, modern periodic table is the long form of periodic table also it is called. So what are the characteristics and what are the main points of modern periodic table that we will try to study. Actually, there were earlier attempts also to classify elements in groups and periods, and Mendeleev periodic table also arranged in groups and periods. In Mendeleev periodic table there were 7 periods only, but 8 group. But Mendeleev periodic table, which was based on atomic mass, increasing atomic mass. But the modern periodic table is based on the atomic number. Modern periodic table. Actually, it was prepared. Modern periodic table was prepared by Niels Bohr. Modern periodic table is based on Moseley's law. Moseley said that atomic number is more fundamental than atomic mass. To classify elements in periods and groups. So, modern periodic law could be stated as the properties of elements are the periodic function of their atomic number. That means if we arrange elements according to their increasing atomic number, then elements with similar properties will occur at regular interval. In modern periodic table, there are 18 groups. There are 18 vertical columns called groups, and 7 horizontal row called periods. First group is of alkali metal, and last group and 18th group consists of inert gases. Metals are generally placed at the left side of the periodic table, and non-metals at the right end. On the right side. Elements are arranged in same group having similar electronic configuration. Having similar electronic configuration. For any particular period, for any element to be placed in a particular period, depends on the number of cells in which the electrons is arranged for that atom. Now we can study general trend in the periodic table. General trends in the periodic table. First, from top to bottom, metallic character in the group increases. From top to bottom, metallic character in the group increases. Let us talk about first group. What we see in the first group? We see in the first group that the first group, which is based on the first maybe hydrogen, but we are not talking about hydrogen, we are talking about metals. You see in the first group the lithium, sodium, potassium, rubidium, cesium, francium. So metallic character in sodium has more in comparison to lithium. That means what? That means sodium can readily lose its electron comparison to lithium. So on, potassium is more electropositive than sodium. That means potassium has more metallic character in comparison to sodium and lithium. So on, francium is most metallic character in the first group, as we see. So this is the trend, metallic character increases. So more electropositive element as we move from top to bottom. That means francium is the most electropositive element here. It has most maximum metallic character. Similarly, in the second group also this is true. In comparison to beryllium, magnesium has more electropositivity. In comparison to magnesium, calcium is more reactive metal because it is placed below magnesium. So on, it can continue up to this iridium. So this is the metallic character trend. As we can see in the first group, francium is the most electropositive. Element in the group. And lithium having least. But non-metallic character decreases from top to bottom. In the group. So fluorine is the most electronegative element. So this is all about in the group. But what happens when we move along the period? When we move along the period, then no doubt metallic character decreases and non-metallic character increases along the period. But if we can arrange the elements along the period, then from left to right, metallic character decreases and non-metallic character increases. We can talk on other trends also, like when we talk about other trends, then one trend is there about size of atom. Size of atom is very important. As we move from left to right, size of the atom decreases. Size of atom decreases when we move from left to right in a period. Size of atom decreases. Let us talk about third period. Example, in third period, sodium is most bigger size in comparison to the chlorine, which is last element of for the group. So size of atom go on decreasing, which are joined. So in the sense, the third period, chlorine will have the least size in comparison to sodium. So in the atomic scale, very important to understand at this level. Electron has a charged particle which is moving then up to which there is no need so in third period, sodium has the greatest size. in comparison to chlorine atom. So these are the important points we should understand about radius of Saigeow. Okay, students, thank you.